Hi everyone, we're starting on Unit 1 of Functions today, Characteristics and Properties. So on to Lesson 1.1 of Functions. I'll start the lecture by defining what a function is. A function is a relation in which there is a unique output for every single input that is inside the domain. There are three methods in which a function can be represented. That's graphically, numerically, or algebraically. And in today's lecture, we'll go through all three of those methods. Example 1, graphically. This is perhaps the most commonly used methods where you have a lot of set of data points and you want to find out the relationship between the value of x, which is the domain, and the value of y, which is the range. Example 2, numerically. Here, shown in the table of values, is the same relationship as the graph that was in the previous slide, but using numbers. When we create a table of values, we need two columns, one for the x, which is the domain, and the other one for the y, which is the range. Example 3, algebraically. This is perhaps a method that will save you the most amount of time, in which all you need is an equation, and in this case it's y equals to x. It shows the exact same relationship as the above two slides, but algebraically. So by now you might have noticed that each function will have an independent variable and a dependent variable, of which x is independent and y is dependent. Example 4, graphically, the vertical line test. So when you give me a function, a graph, how would I know if the graph represents a function? Well, I can use the vertical line test. When the relation between independent variable and dependent variable are 1-to-1, then it is a function. State if the following are functions or not, and why. Let's take a look at the one that's on the left first, the first example. The vertical line test allows me to draw numerous amount of lines that are parallel to the y-axis. And what I'm looking for is the number of intersection between the line that I have drawn and the actual graph itself. So let's take a look at the line that I have drawn already on the left side, this one. And take a look at the number of intersection. There's only one. And it doesn't matter where I draw my straight line, there will only be one intersection. Therefore, I can conclude that the graph on the left side is a function. Let's take a look at the one that's on the right side. And look at the number of intersections between the vertical line that I have drawn and the actual graph itself. There's 1 and 2 intersections. And it doesn't matter where I draw my straight line, there will always be more than one intersection. Therefore, I can conclude that the one on the right is not a function. Example 5, algebraically, creating a table of values. Here we have the equation of f of x equals to 1 over x squared. And I draw all the information into a table of values, in which there's two columns, one for x and the other for y. The one on the x can be any number that I want, and as many as I want. And for this example, I chose -3, -2, -1, 0, and 1. What I do is I use these values and I plug it into the original equation. And I will see what I should get for f of x, and that will be my y value, which I write on the right side of this table of values. And when I plug in -3 for x, I get 1 over 9. When I plug in -2, I get 1 over 4, and so on. What I'm looking for is the amount of y that I get. And as you can see, for all the values, no matter what value I put in, I will only get one y value for each x value. Therefore, I can conclude that it is a function. Example 5, numerically, mapping a diagram. State if the following are functions or not, and why. This is perhaps the easiest method, in which all you need are two large ovals, one being x, the other one being y. And then I would fill in the number that I would want being my x, And in this case, I chose -2, -1, 0, 1, 2, and 3. And I will try to find the corresponding y. Then I will map it out and connect the x in which I get from the y. So with -2 being the x, I got 0. With -1 for x, I got 1 for y. What I'm looking for is that 1x goes to only one y. In here, -2 went to 0, -1 went to 1, and so on. You may be confused by the last two cases in which 2 went to 4, but 3 also went to 4. But it's okay because 1x went to only one y. It will not be okay if 1x goes to 2y. So for this, I can conclude that for each input, there is only one output, and therefore it is a function. And that marks the end of this lecture. And remember, practice makes perfect, so please do the end of chapter questions as well as your assignment, and I'll see you next lesson.